Example 6. You'll notice the difference between example 6 and examples 4 and 5. Example 6 is a subtraction problem over a single number instead of a product, instead of a multiplication problem. So what I want to look at here is I want the top to be factored by a greatest common factor, just like we did all the other first 3 problems today. So what's the smallest number that divides into 3 and 9? 3. And what's the smallest x that divides into x and x squared?
X first.
X the first, right? And if I take 3x out, 3x divided by 3x equals? 1. And that 1 is, again, a required 1. 3 divided by 3 is 1. X divided by x is 1. Everything went away. The 1 has to be left there. Okay, notice this has a minus sign, so I'm going to write a minus sign. And then if I do 9x divided by 3x, so 9 divided by 3 is 3. And x squared divided by x is? X to the first. All that's on top of 3x. As I'm factoring the top, the denominator stays as is. It's still part of the problem. It should be rewritten. Okay? Once you get to factored form, again, we're at the same place we were in examples 4 and 5. I've got a factor being multiplied by a factor over a factor. All right? And 3x, you might think of, well, that's two things, 3 and x, but 3 times x, they're being multiplied together, right? So really, 3 is a factor all by itself, x is a factor all by itself. Well, you can't see that. Let's try something else. Not screen. 3 is a factor all by itself, so is x, and then I don't even know what to do about this one here. This 3 is a factor all by itself, so is this x. All right, there we go. Because officially 3 is being multiplied by x, so 3 is a factor, x is a factor. So looking at this, 3 matches 3, cancel, cancel. X matches x, cancel, cancel. This 3x also matches 3x, but it's attached to a 1, so these work together. Okay, algebraically, we say these are said to be married. When you add or subtract things, they're married to each other, so you have to work with them as one whole unit. Okay, so 3 cancels 3x, cancels x. What's left over is 1 minus 3x, and that's the answer. Okay, here's the common mistake on this problem. Let me show you what I see a lot of people do. That's what a lot of people do. They don't pay attention to structure. Hey, that divides by that evenly, divide it. That's not legal because you didn't divide that. They don't have to divide. So that's not legal. So, illegal.
Illegal math right there.
That symbol means illegal. All right, that red symbol.
Art of a dog. That's all I have to say.
It's balancing on a donut. Whatever this is balancing on a donut.
It's eating a donut. That's really
It could be eating a donut too, I suppose.
It's going through the donut hole.
Oh God.
I don't know.
I don't think it's gonna fit.
It's kind of
Okay,
scary.
this is